Well, welcome back. We have what seems like a pretty simple topic. We're going to hit sum, product of the roots, along with a discriminant. Now, I've tried to pick the toughest questions I could find for you, so make sure you're taking notes of all the examples tonight. So let's just slow down and take a time out and remind ourselves what the sum and product equations are. Okay, now remember, this is of a quadratic. You have to have the ax squared plus bx plus c equal to 0 first. Then we can easily state the sum, and you probably have already written them down before I have. That sum is negative b over a, and the product is c over a. Okay, now the question can't get much easier than question 1 is right here, and it simply just state the sum and product. Okay, so the first thing I check is the formula set equal to 0? Does it look like that ax squared plus bx plus c equals 0? And it does, of course, so then I'm just going to apply my formulas. Make sure you state s for sum equals negative b over a, and then I'll just plug my numbers in. Remember, it's ax squared plus bx plus c. So my b in this case is 8, so I'm going to put a negative 8 actually, divided by my a value of 2, so I would say my sum is negative 4. My product is c over a, and again we're just going to jot that down. P equals, my c value is negative 3 over 2. And there's the product of the roots. Now notice, I don't actually know what the two roots are. I know, and here's what I want to really stress in your notebook. I know that root 1 plus root 2 has to equal negative 4. Definition of sum means you add two things together. And I know root 1 times root 2 has to equal negative 3 halves. Definition of the word product. Okay, and that's really what we're hinting at. We don't actually know what the two roots are. We just know what they add up to and what they multiply to. Now don't get me wrong, you could easily find these roots out by factoring or using quadratic formula, but that's not what we're doing today. Alright, so like I said, I tried to make each question a little more difficult, not as basic as that. So this question says, find two different equations, quadratic equations, who could have roots such that the sum is equal to 9, so I'll jot that down, and the product is equal to 6. Now, there's actually an infinite amount of quadratic equations that have this same product, a product of 6 and a sum of 9. And it's very simple. Just use those two formulas. Sum equals negative b over a. And what value do you now know? Do you know the s, the b, or the a? Well, they told us the sum is 9, so I'm going to say 9 equals negative b over a. All right, and that's about as far as I can go. I don't know anything else. Let's move over to the product one. Well, I know the product formula is c over a, and out of the p, c, and a, I know the p part is 6. So 6 equals c over a. Now here's how you can get different equations. Remember, the a is just that leading coefficient, ax squared plus bx plus c. And a, we like when a is a 1, so the first thing I'm going to do is I'm going to replace the a with 1 and say 9 equals negative b over 1. 6 equals c over 1, therefore b is actually equal to negative 9 when I divide that, and c is equal to 6. So one quadratic equation could be 1x squared. Now think about what you'd want to have with your x, and what you'd want here, so that the sum is negative 9, and the product is 6. Would you want a positive or negative 9 here? Well, I'm thinking I'd want a positive 9 because, again, the sum is negative b over a. And here I would want a positive 6 because the product is going to be 6 over 1, or c over a. Now, how could I get another equation that's similar? Well, basically, I can just change this value of a. A doesn't have to be 1. What if it has a coefficient? All right, so let's say that 9 is equal to negative b over a, and 6 is equal to c over a. You can pick any number you want for that coefficient. Maybe you want it to be, I don't know, 4. Negative b over 4, and 6 equals c over 4. Now resolve for your b and c. 9 times 4 is 36, equals negative b, so b is going to equal 36. And that's 24 is equal to c. Okay, and again, I'll just rewrite my quadratic equation. This time, though, it's going to start with a 4x squared. Okay, plus something x plus something c equals 0. Notice I have this equals 0 every time. Okay, now, If the sum we said was -9, what number would I put here? Positive or negative 36? Hopefully positive 36. And my C value is also going to be positive 24 because I want the C over the A to get me 6. So again, you could put any number you want in for A to get different versions, and you could quickly check it. If you do negative 36 over 4, do you get -9? Sure. If you do C over A, 24 over 4, do you get positive 6? Sure. And it's real easy to check. All right, another similar one. Write a quadratic equation that has the roots 5 plus or minus radical 7. Okay, now notice it says roots because there are two of them there. Root 1, and let's just mark it as R1, is 5 plus radical 7. And root 2 then is 5 minus radical 7. Well, just keep saying to yourself, you need two things. You need a sum and you need a product. All right, so how do you get your sum? Well, a lot of people are probably saying negative B over A, and my product is C over A. Now, do you actually know any one of those values? Do you know the sum? No. Do you know the product? No. You don't know B and you don't know A. But again, just go back to the basics. Sum literally means add. So just take your two roots and add them. 5 plus radical 7 plus 5 minus radical 7. The radical 7's cancel, and I can tell you that the sum is 10. Same thing, product back, in elementary school meant multiply. So let's do that. 5 plus radical 7 times 5 minus radical 7. So I've got 25 plus 5 radical 7 minus 5 radical 7. This will be a negative. Any radical times only itself, the radical disappears and I get -7. Therefore, I know the product, those cancel. 25 minus 7 gets me 18. Now again, you're not done there. All that did was it figured out the sum and it figured out the product. So let's make a note. If I know the sum is 10 and the product is 18, I'll just plug those in the formula. 10 equals negative B over A, and 18 equals C over A. And remember, to write the equation, you can pick any number you want for A. All right, and the reason I'm picking A is because it's in both equations. So let's say you want A to be 1. Most people like letting A be 1. Oops. So I would say C is equal to 18 and B is equal to 10. And now I'll just rewrite the equation. All right, I said that's 1x squared. I'm going to need something with an x, and my C equals 0. Okay, so remember, I want the sum to be, oops, that should have been a negative 10. Thanks for catching me there. I want the sum to be 10. That means this would have to be a negative 10, and the product would be a positive 18. And if you're not sure how to figure out the plus or minus, just think about it. You need the negative B over A to equal 10. What number do you want that to be? All right, we'll keep chugging here. Let's see, this time a quadratic function has a leading coefficient of 5. So let's just stop there. The leading coefficient is the A in the ax squared plus bx plus c. So right there, they're telling me A equals 5. And the sum is equal to negative 8. So root 1 plus root 2 is equal to negative 8. Or I can just say the sum equals negative 8. And the product is 14. So root 1 times root 2 is equal to 14. So it basically tells me those two things. I know the sum and the product and what they stand for. So again, I basically need to figure out what B and C are. And it's very simple. Just use those two formulas. Sum equals negative B over A. We just said the sum is negative 8. And I know the A value has to be 5. They told me that, the leading coefficient. All right, I can multiply, so negative 40 equals negative B, therefore B equals 40. And I can do the same thing with the product idea. Product equals C over A. My product is 14 equals C over 5. Let's see, C equals 70. All right, and now just write the equation out. That's simple. 5x squared, I need something with an x, and this something c there equals 0. Okay, remember, c over a is always going to be that same value, so it's going to be plus 70 over 5 to get me the 14. That checks. Now, what divided by 5 is negative 8? Well, that's going to be a negative 40. And just take 2 seconds and make sure it works. Now, we've seen this type of question on our practice Grizzlies the past few times here, so let's just slow down and go through this carefully. This time it says, what is the value of k if they give you this equation and x equals 12 is a root? Notice this is not the sum or product. This is one of the roots. I can't stress that enough. Okay, but it's still a sum and product question. So let's start with sum. Sum equals negative b over a, product equals c over a. And I'm going to plug in anything I can to both of them. I know the sum is equal to, I have to negate this, so I'm going to say it's k over 1. Hopefully you see the a value is 1, the b value is the negative k, and the c value is negative 36. And I'm going to say the product equals negative 36 over 1. Now, in theory, I really only know one of these values. I can't actually figure this one out because I have 2 variables. But I can figure this one out. The product is clearly negative 36. Okay, now, watch how simple this is. Remember, this is the product of the roots. Root 1 times root 2 has to equal negative 36. You happen to know one of the roots. One of the roots, we said, is 12. So 12 times root 2 is equal to negative 36. All I have to do is divide by 12. And I know the second root is equal to negative 3. Okay, now, that doesn't actually answer the question. That tells me the other root. I know one root is negative 3, and the other root is 12. So let's just mark that down. Okay, now let's go back and answer the question. What is the value of k? Now, k is in the place of b, right? So now you can figure out the sum. You know the product is negative 36. If you multiply those two, you get negative 36, and now you can get the sum. It's really just root 1 plus root 2. So 12 plus negative 3 is equal to 9. Therefore, that is the sum of the roots. So I can go back and figure this out now. The sum, we said, is equal to k over 1. And I now know the sum is 9, so 9 is equal to k. Okay, 9 is equal to k. And the question just says, what is the value of k? And we've got it figured out nice and easily there. All right, so just be careful. When you figure out the sum, figure out the product, and you're in good shape. All right, one last one I promise you on sum and product. Very similar to the last one. This time they told us 2 and 3 are the roots. So I'm just going to make a note. Root 1 is 2, root 2 is 3. Doesn't really matter the order at all. What is the value of k? So again, it just comes back to a sum and product question. So I'm going to say the sum equals negative k over 1, and the product is equal to 6 over 1. And again, you know one of these. You can't figure this one out because there's 2 variables, but clearly the product is 6. Now let's verify that. That means if you take root 1 and multiply it by root 2, you better get 6. Well, 2 times 3 is 6. That is definitely true. Could you figure out the sum? Of course you can. It's that simple. Sum means add. The sum is equal to root 1 plus root 2. So 2 plus 3 is equal to 5. The sum of the roots is 5. So now you can go figure out k. 5 is now equal to negative k over 1. So k is equal to negative 5. Well, that gets us halfway there. The second half of this review video is all about the word discriminant. Okay, now, discriminant is easy to remember because it's part of another formula. It's actually part of the quadratic equation. Okay, now, it does not include the radical. It's just the junk, so to speak, under the radical. So it's x equals negative b plus or minus the square root, here it goes, b squared minus 4ac. That is the quadratic equation, the discriminant. No radical. All right, so there's 4 cases. So let's just slow down and go through the 4 cases. This case, and this is what needs to go in your notebook, the discriminant is a perfect square. So you go ahead and do it. My b in this case, that's 3 squared minus 4 times 1 times negative 10. I get 9 plus 40. I get 49. Okay, so the discriminant is a perfect square. 49 is a perfect square. Now to describe the nature of the roots, and that's the important part, here are the key words you want to keep in mind. The roots are real, okay, they're not imaginary. 49 is a real number. And because it's a perfect square, we use the word rational. And we just like to think that perfect things are rational. And the other key word is unequal. Okay, now, graphically, I just want to be clear. It's going to look something like this, where it has two fairly nice roots. Okay, they are unequal. They're not hitting at the same spot. The roots are unequal. One's here and one's here, not equivalent. The second case is going to look something like this. This time, you get a number that's just not a perfect square. All right, that's what I need in your notebook. Case 2, not a perfect square. Let's do our discriminant. Negative 6 squared minus 4 times 1 times 7. So that's 36 minus 7 times 4 is 28. And that gets me a nice answer of 8. Okay, now, how does that change? Still real numbers. I want to be very clear. Still real. This time, instead of using the word rational, because it's not a perfect square, we're going to say it's irrational. Okay, and that's key there, irrational, and I still want to be clear, they are unequal. Unequal. Okay, so again, it's going to look fairly nice. You're going to see two roots, not equal, not at the same point. And again, that picture should help you a little bit on some multiple choice questions. All right, the next two cases are pretty distinct. This time, you actually get 0 as your discriminant. So let's say we've got negative 10 squared minus 4 times 1 times 25. That's 100 minus 100. You get a big fat 0. Here's where our lingo changes. We're still going to say the root's real because 0 is still a real number. Okay, but this time, here's your key word. The roots are equal. Okay, we want to be very clear on that. The roots are equal. Now again, what do I mean by equal? That means, well, both roots, for example, are x equals 2. So maybe you factor x squared minus, oops, not that. Maybe x squared minus 4x plus 4. So I would factor x minus 2 and x minus 2, and I get x equals 2 and x equals 2. Okay, they're equal. They're the same number. So what does that mean? Well, if you're going to hit the same number twice, that means you are looking like this. And this is called, again, it touches once, tangent to the x-axis. All right, so let's get that picture in there. Let's be clear that the roots are equal to 0. That means they have equal roots, so it's tangent to the x-axis. And that's a big deal on the picture-wise. Let's make sure we understand the difference between two unequal roots versus two equal roots. And lastly, case 4, the discriminant is less than 0. This is always the obvious one. So let's go ahead. We got negative 8 squared minus 4 times 1 times 20. That's 64 minus 80, which gets me a negative 16. Now, I don't care that 16 is a perfect square. The key is that this is negative. And anytime that happens, we have the easiest answer of all of them. We are now imaginary. Our roots are imaginary. Okay, now what does that mean graphically? Well, remember, roots are where your graph crosses the x-axis. If they're imaginary, that means they don't cross the x-axis. So your graph is going to lie completely underneath the graph, or it could lie completely above the graph. The idea is it's impossible to ever touch the x-axis. Alright, I'm hoping to fly through these questions. Notice they're describing the discriminant, so I'm just going to start with that formula, b squared minus 4ac. I've got 4 squared minus 4 times 1 times negative 7, 16 minus, plus 28. Gets me a nice 44, I believe. Alright, so I'm just going to look at that number. Clearly it's not negative, that kills imaginary. Rational meant perfect square, that's out. Okay, now between these two, well this is rational so it's out, and equal is only for the number 0. I'm going with option 3. Irrational, not a perfect square. Which of the following has imaginary roots? Now, you could sit here and do the discriminant 4 times. That's great, good for you if that's what you want to do. I, on the other hand, I'm going to use my calculator and I'm going to graph it. Okay, now why would it be smart to graph it? If my roots are imaginary, what will my graph look like? How many times should it touch this axis if it's imaginary? None. So again, I'm looking for my graph to be either completely below or completely above. Okay, and that's how I would attack this one. I would graph each one in y equals 1 at a time, and I want to make sure that graph never touches the x-axis. Alright, again, I'm not going to solve this one for you, but you've got the idea. And lastly, which equation has roots that are real, rational, and equal? Well, hopefully your gut's pulling out that word rational, and you're saying you need your discriminant to be a perfect square. And that's the key word there, perfect square. So I would just take my time, go through each one, and see which one is a perfect square. Alright, well that does it for our review tonight. We look forward to seeing you in class tomorrow.